brilliant. What an awesome climb. Magical place. It's like Mother Nature created this place for rock climbers.
Some climbers prepare to spend the night on El Capitan, hoping to climb the next day. It's easy to imagine that the Ice Age shaped only remote mountain ranges, but it also left a legacy that has affected millions of people. Take, for example, Manhattan, the island at the center of New York. When you look at it from a distance, it's actually got a very distinctive profile. There are two clusters of skyscrapers with much lower buildings in the middle. This is a direct result of the Ice Age. "20,000 years ago, this part of America was at the edge of a vast ice sheet that covered much of the northern hemisphere. The ice would have towered over any modern skyscraper. When it retreated, just as in Yosemite, the ice left behind these boulders and rock smoothed and polished by ice. The ice exposed a hard bedrock called schist, solid enough for sinking deep foundations to support tall buildings. Without this bedrock, New York couldn't have been built so high. The one part of the skyline that dips is the one place where the ice sheet deposited loose sand and gravel. No good for building towering skyscrapers. Ice has bulldozed and carved the world we know on a colossal scale. But what is it that gives something as brittle as ice supremacy over the hardest and most resilient rocks to be found on the planet? I've come to one of the only places on Earth where you can really see ice in action, not just by looking at it from afar, but by getting up so close you can see its inner workings. It's thanks to this glacier that we've started to unravel the mysteries of ice's great power. In Norway's Arctic Circle lies the Svartisen Glacier. I'm here because the Svartisen has something unique. You can see how it works not just from the outside, but from the inside. It's one of the only glaciers in the world with a back door. This is part of a 50-kilometre-long network of tunnels. They were built for a big hydroelectric power station, but they'll also lead me right inside the glacier. I usually study volcanoes, and in a way, glaciers are just like volcanoes. They're beautiful, dangerous, hard to get to, and even harder to study. Also, like volcanoes, a lot of the action goes on, you can't see it. In the case of a glacier, it goes on underneath hundreds of meters of ice, right where it meets solid rock. Which is why I'm in this tunnel, and I'm heading in that direction for another 1.5 kilometers. In a chamber at the end of the tunnel, you come face to face with ice. It takes scientists 2 days of hard graft using hot water to melt a cave in the bottom of the glacier. Big enough to get inside and see exactly what happens when ice meets rock.
Here's the ice tunnel. Watch your head.
Miriam Jackson's a glaciologist. She spends up to 3 weeks at a time down here.
Look at that. It's beautiful.
It's amazing, isn't it?
It's absolutely beautiful. This is like a piece of art. It is, isn't it? Wow.
You got to remember there's 200 metres of ice over us now.
200 metres.
Yes, we're at the bottom of the glacier and the ice is over us. It's also closing in on us.
As we speak, it's contracting in, or?
Yeah, if we couldn't stand here for 48 hours, the ice would close in on us.
We'd be stuck fossilised in the ice, like a big ice cube.
It's down here, right at the very bottom of the glacier. You can see how it carves out great landscapes and can slice through solid rock.
This is the bottom 2 metres of the whole ice, of the whole glacier. And this is what's doing all the erosion. And there's a lot of sediment in it, a lot of rocks in it, and these are being carried along all the time. They're being scraped up off the bottom. And all those particles are wearing away for years and years.
Right.
So the beautiful glacial valleys that you have where glaciers used to be were carved out by this kind of thing.
It's not the ice itself that does all the damage. It's the debris that it picks up along the way that makes glaciers act like giant sandpaper. In effect, the ice uses the rock against itself.
There's a little rock here. It's been travelling in the ice now for perhaps the past 1,000 years.
That is amazing. It's amazing to think that when that first fell in, what was happening on the planet was Genghis Khan sweeping across Europe or something like that.
Yeah. You can get really big ones, you know, 1 metre across, but they found rocks being carried by glaciers as big as a house.
Really?
They can be huge.
But the ice cave has another surprise, one that offers a clue as to why something as apparently solid as ice can also bend and flow.
Have you seen this?
It's an air bubble, is it?
It's not an air bubble, this is water
Oh,
here.
look at that.
So this is, we opened this up when we were melting. But before then it was totally enclosed in the ice. The interesting thing about these is when we're melting, sometimes they might drain on us all of a sudden. And these can be a decent size, 20 litres or more, and suddenly you find this little gush of water coming down on you. It's a bit hard to see just because of the effects of melting, but the ice is full of these near the base, and they're making the ice softer.
These water pockets may help explain how ice can flow. The glacier is not the solid mass that it first appears. Seeing it from the inside has given me a completely different perspective.
Really, what I'm looking at here isn't solid ice at all. It's almost spongy.
Yeah, so it feels very hard,
Yeah.
but it can flow.
It's weird stuff, isn't it? I thought I knew it, but this is weird. It seems almost alive.
As if to prove the point, the ice invades the space we've left behind. In just 3 days, our magical ice cave disappears. From space, you can really see how fluid ice is. On the west coast of Greenland, glaciers flow around the contours of a landscape hidden beneath the ice. A false colour image reveals the blue ice of the Malaspina Glacier in Alaska. It flows through a gap in the mountains and spreads out like syrup for more than 50 kilometres. This is part of the Lambert Glacier in Antarctica. It's one of the longest glaciers on Earth. You can follow its flow lines as it bends and twists on its slow-motion descent. Ice is soft and bendy, yet it's also powerful enough to destroy almost everything in its path. But while glaciers usually take tens of thousands of years to sculpt a landscape, occasionally they can trigger a devastating change that happens in just a few hours. You can see the aftermath of one such event in the northwest corner of the United States. It's a land of gorges, canyons and barren rock covering 40,000 square kilometres. It's known as the Scablands. Vic Baker is a geologist who has spent 40 years trying to discover exactly what took place here.
The landscape creates this impression of something fantastic that happened. And as you drive through it, you can have